A warm greetings to all. Welcome to this video. Today we are going to discuss about volume of the sphere x squared plus y squared plus z squared equal to a squared by using Cartesian coordinates. Myself K. M. Sarish Kumar from Kamaraj College of Engineering and Technology, Virudhunagar, belongs to Mathematics Department. Okay. Before we start this problem, in the previous video we have discussed about the same problem by using spherical polar coordinates, but in this section we are going to use Cartesian coordinates. Okay, now come back to the problem. Here we are having only two categories. One is to find the limit and another one is to find the integration part, to solve the integration part. Step number 1, to find the limit. Here the equation is x squared plus y squared plus z squared equal to a square. We have to consider any two of them equal to 0. So let us assume that x is equal to 0, y is equal to 0. So what we get, z square equal to a square. Therefore z is equal to plus or minus a. So z limit is over. Next one, we should take x is equal to 0. What we get, y square plus z square equal to a square. Then y squared is equal to a squared minus z square. Then y is equal to plus or minus square root of a squared minus z square. Next, to find the limit x. That's why x squared is equal to a squared minus z squared minus y squared. Then x is equal to plus or minus root of a squared minus z square minus y square. So our limit is, limit of the problem is x varies from minus square root of a squared minus z square minus y square to root of a squared minus z square minus y square, and y is minus root of a squared minus z square to root of a square minus z square. Then z limit is minus a to plus a. So first part is over. Next, to find the second part. Now the second part of the problem is to find the required volume. So required volume is equal to triple integral over v dv. So here the limit minus a to a minus square root of a squared z squared to root of a squared minus z squared, and the third limit is root of a squared minus z squared minus y squared to root of a squared minus z squared minus y square. Here the x limit, y limit, z limit depends on the dimension dx, dy, dz. And we studied in the lower class, we have all the properties. The property is minus a to plus a. In general, minus infinity to plus infinity, f of x dx is equal to 2 into 0 to infinity f of x dx, when f of x is an even function, and as well as here the function is an even function. That's why we should write the same concept. The limit is 2 into 0 to a, and here we have also the same kind of problem, 0 to root of a squared minus z square, and the next one 2 into integral 0 to root of a squared minus z square minus y squared dx, dy, dz. So finally what we get, 2 into integration, 2 into integration, 2 into integration. So taking outside the constant, so what we get, 2 into 2 into 2, 8. So the next line of the problem is 8 into integral 0 to a integral 0 to root of a squared minus z square, integral 0 to root of a squared minus z square minus y squared dx dy dz. Now integration with respect to x. So the result is 8 into integral 0 to a integral 0 to root of a squared minus z squared. Now integration of this result dx is x. So 0 to root of a squared minus z squared minus y squared dy dz. Now applying upper limit and then lower limit. So here the upper limit of the problem is 0 to a 0 to root of a squared minus z squared, and the equation of the problem is a squared minus z squared minus y squared dy dz. Now again integration, then limit substitution. Now come back to the integration formulas. Already we have one formula. That formula is integral root of a squared minus x squared dx. Compare this equation. A squared minus x squared dx equal to x by 2 root of a squared minus x squared plus a squared by 2 sine inverse of x by a. Now compare with this equation. Here the integrand variable is y, so that's why y is equal to x. And the next one, a squared is equal to a squared minus z squared, a squared by a squared minus z squared. So that is the equation. Now replace this equation in terms of this problem. So what is our result? 8 integral 0 to a. Now the integration part, the formula is y by 2 root of a squared minus z squared minus y squared plus a squared by 2. So a squared means a squared minus z squared. That's our answer, by 2 sine inverse of x by a. Here x is equal to y, that's why y by a. So a value is root of z square minus a square minus z square. Now applying upper limit as well as lower limit. So here the upper limit is a square minus z square and the lower limit is 0. So now substitute the result. So substitute the limit 8 integral 0 to a. Now substitute upper limit, the result is 0 plus here a squared minus z squared by 2 sine inverse of upper limit, sine inverse of the upper limit is a squared minus z squared divided by root of a squared minus z squared. Then lower limit is obviously 0. So finally the lower limit is 0. That's why the result is sine inverse of 1. Therefore 8 0 to a squared minus z squared by 2 sine inverse of 1 into dz. Here sine inverse of 1 value is pi by 2 and 2 is a constant taken outside. So 8 by 2 into pi by 2 integral 0 to a squared minus z square into dz. Now cancel, will get the answer is 2 pi. Integration of a squared, so a squared is z, because there is no integrand variable, that's why the constant is a squared. Integration of constant means a squared is z, then integration of z square z cube by 3 0 to a. Now substituting upper limit as well as lower limit. Lower limit obviously 0, so no need to explain it, and upper limit is a. Now substitute here 2 pi a squared into a minus a cube by 3. Therefore, the result is 2 pi within the bracket a cube, take the LCM, 3a cube minus a cube by 3. Therefore, the result 2 pi 2 a cube by 3. So, finally, the result is 4 by 3 a cube. That is our answer for volume of the sphere. So, finally, what we get? Volume of the sphere is equal to 4 by 3 a cube cubic units. That is the solution of Cartesian coordinates. Thank you.